Welcome back, students. This is the session 2 of wave optics, and the topic is Huygens principle. So, before discussing about this topic, I would like to define the wavefront. So, what is a wavefront? So, I will be explaining it with the help of an example. That is, when we drop a small piece of stone in a pool of calm water, then what happens that ripples are generated which move in the outward direction, that is away from the point source. Now the points on those ripples which are oscillating in phase, or you can say all those points which are at the same distance from the source, constitute, or you can say the locus of all those points which are oscillating in phase, or the locus of all those points which are at the same distance from the source, constitute the wavefront. So these are the two wavefronts which I have made here. The first one I have, that is P dash, is called, I have indicated it as a primary wavefront, and S dash is the secondary wavefront. I will be explaining about this primary wavefront and the secondary wavefront later on. And this is the source. This is the source, means it is the point source, or you can say the point of impact. So now these wavefronts are composed of many wavelets. I have already indicated, or I have drawn these wavelets with the help of dotted lines. So these wavefronts are composed of many wavelets, and the common tangent to these wavelets constitute the wavefront. So these are the wavelets, and I have made the common tangent. So the common tangent, when we make a common tangent to all these wavelets, then we get the wavefront. So the first wavefront is called the primary wavefront, and each and every point on the primary wavefront acts as a source for the secondary wavefront. So when the primary wavefront is generated, then the each and every point on the primary wavefront acts as the source for the secondary wavefront, and each and every point they generate these wavelets, and when we draw a common tangent, we get a second wavefront, which is called the secondary wavefront. Now these wavefronts, as you can see here, they are spherical in shape, but when they are at a large distance from the source, then they are considered as a plane, and they are also called a plane wave. These wavefronts, as I have already told you, that they are composed of many wavelets, and the common tangent to these wavefronts gives the common tangent to these wavefront give rise to common tangent to these wavelets, sorry. Common tangent to these wavelets give rise to wavefront. Okay, so this PB dash is the primary wavefront. Primary wavefront means it is the first wavefront which is created by the locus of all the points which are oscillating in phase, or it is the locus of all those points which are at the same distance from the point source, or which are oscillating in phase. And each and every point on these on this primary wavefront, it will act as a source for the secondary wavefront. That is, each and every point will generate wavelets like this. They will generate wavelets, and when we draw a common tangent, to these wavelets, we will get the secondary wavefront as indicated here. So now we will come to the Huygens principle. The Huygens principle, Huygens stated that the light wave travel like the ripples in water. Light wave travel like the ripples in the water, as I have just means I have just tried to explain the this wavefront with the help of the example in which I have taken the case of you can say of throwing a stone in a pool of calm water. So Huygens said that light waves travel in space like the ripples in the water, and the locus of all the points which are at the same distance from the source or which are oscillating in phase constitute the wavefront. The primary wavefront, all the points on the primary wavefront will act as the source for the secondary wavefront, or we can say that all the wavelets of this primary wavefront will act as a source of wavelets for this secondary wavefront, and when we draw the common tangent to these wavelets, then we get a wavefront which is called the secondary wavefront. Now, in the Huygens principle, there is one limitation also. That is, Huygens was not able to explain the backward. This is the wavefront which is propagating. That is, light is propagating in free space like the ripples in the water, and the light is propagating by the generation of the secondary wavefronts. The secondary wavefronts are generated due to these primary wavefronts, because all the points which are all the points on the primary wavefronts, they act as the source for the secondary wavefront. That is, all the points, they are basically the source of these wavelets. And these wavelets, when we draw a common tangent, then we will get the secondary wavefront. So light is traveling in space like the ripples in the water, and the light travels due to the propagation of the secondary wavefront. These secondary wavefronts are generated from the primary wavefront. But Huygens principle has got one drawback, that it was not able to explain properly the formation of the back wave. I will be just drawing it here. So this is the back wave, and let us say I am just denoting it with the let us say it is d dash. So this d dash, this one is called the back wave, and you can here see there it is a back wave, means that the light is propagating in the forward direction with the help of these primary wavefront. That is the primary, each and every point on the primary wavefront is acting as a source for the this secondary wavefront. That is, each and every point is generating wavelets. These wavelets, when we draw a common tangent to these wavelets, we will get another wavefront, which is called the secondary wavefront. Okay, na? So now Huygens principle was not able to describe. This is the wavefront which is propagating in the forward direction, but there is also the generation of the wavefront which is propagating in the backward direction, which is called the back wave, or you can say the back wavefront. Huygens said that the amplitude of vibration of these wavefronts in the forward direction is maximum, and the amplitude of vibration for these back wave is 0. So therefore he said that there is no generation of the back wave. However, there is a generation of the back wave also, and but Huygens was not able to explain it properly. So this is the back wave, that is the D dash is the back wave, and these are the wavelets of this back wave. So so in short, Huygens principle said that light wave travels in the space like the ripples of the water due to the propagation of the secondary wavefronts. The secondary wavefronts are generated from the primary wavefronts. These wavefronts are spherical in shape, but when the distance of these wavefronts is large from the source, then these wavefronts are considered as plane wave. So, or these are considered as a plane or plane wave. So, using this concept, we will be now discussing about the laws of this refraction and reflection for the plane wave in the next session. So thank you very much for joining, and I hope you have understood this the short description about this Huygens principle. And in session number 3, we will be discussing about the laws of reflection and refraction of the plane wave. So thank you very much and have a nice day. Bye.